Hello, and welcome to this video for the BTN 710 course. This is for Assignment 1, Deliverable 4. I am Joshua, and with the assistance of my two team members, Brett and Ina, today we will be talking about the EternalBlue exploit. This exploit has done a large amount of damage to a number of firms over the past few years, and this exploit is often difficult to detect. Today, we're going to talk about three main topics regarding the exploit. We will be discussing a basic summary of the exploit, how the attack method works, as well as the security policy, including how to prevent against it. We hope that you're able to learn something new from this video, or just to gain insight about the EternalBlue exploit. In addition, we also hope you learn something new about information security. Without waiting any longer, I'm going to hand it off to Brett to tell us about the EternalBlue exploit.
The Windows SMB remote code execution vulnerability is an exploit that takes advantage of sending custom crafted packets to the host running the server message block version 1 version, which will then mishandle the packets so long as they are designed in a certain way. This will then allow for arbitrary code to be executed on the target computer. This arbitrary code opens up the way to further exploits, or even can be used to take control over the computer to compromise the rest of the network. The operating systems affected by the SMB remote code execution vulnerability, specifically the instance CVE 2017-0144, include Microsoft Windows Vista SV2, Windows Server 2008 Service Pack 2 and R2 Service Pack 1, Windows 7 Service Pack 1, Windows 8.1, Windows Server 2012 Gold and R2, Windows RT 8.1, Windows 10 Gold 1511 and 1607, as well as Windows Server 2016. This instance of the Windows SMB remote code execution vulnerability focuses on the server message block protocol, specifically the version SMB v1. There are a lot of names and variants for this exploit. Perhaps the most famous are EternalBlue, as well as the modifications EternalRocks and Microbot MassiveNet, which are all built upon this exploit, as this exploit is the gateway. Blue Keep is a very similar vulnerability, hence the naming scheme similarities, and is far more recent than EternalBlue, 2017 for EternalBlue and 2019 for Blue Keep. Another implementation of a variant including this is the Double Pulsar Payload Execution. A notorious version of this variant is a specific version of the Petya ransomware, which used this exploit to take control of the computer in order to ask for a ransom. Other variants of the Eternal family, similar to EternalBlue, include Eternal Romance, Eternal Champion, and Eternal Synergy, which were all released by one group, the Equation Group.
We are now going to take a look at how the attack aspect of this exploit works. In order for us to get a better understanding of the attack, it is important to look at a diagram of the network. The original diagram would include an initiating computer, which would be an attacker, as well as a target computer. In order for the attack to be viable, the target computer must be running the server message block version 1 system. Assuming our target is using the server message block version 1 system, our network would now look like this. The only connection that is required is from the initiating computer to the target computer. This allows the attacker computer to run remote code. While only one connection is required, that is often not the main goal while using this exploit. The attacker will then use this connection in order to connect to a number of other computers that share the same network as the target computer. We will now discuss how the exploit works. The CVE-2017-0144 exploit is utilized when an unauthenticated attacker sends a maliciously crafted packet to the server, which allows them to gain access to other machines on the network by taking control of the machine that was running SMB version 1. EternalBlue is one of the specific implementations of the CVE-2017-0144 exploit, and it relied upon a function detailed as the following. The exploit works primarily on three different faults within the SMB program. The first fault is a mathematical error that occurs when a cast is made between an FEW list structure to an NT FEA structure in terms of how much memory to allocate. The error in memory allocation is what allows for a buffer overflow. The second bug relies on the difference between these two requests. Both of these have fallback commands when more data is needed, but they do not go about it in the same way. Both are able to run commands where it will assign the type and size of both packets, but this is based on the type of the last one received. Due to this, the packet will allocate more space than it actually needs, which allows for hiding of the code. Now that the packet is made, it relies on one more bug in order to run the code hidden within the malformed packet. The third and final fault allows for heap spraying, which means that the attackers can allocate memory at a specific address, and from there, execute shellcode to take control of the system. There are three main steps needed to run the EternalBlue exploit and gain access to a victim network. The first thing to do is some initial scanning. This will determine if the target computer is running SMBv1. If it is not, then there is no need to run this attack as it will not be effective. This can be done in the Metasploit modules by sending an echo command, as seen in the screenshot below. The second step is to create the corrupted packets. This will allow for the overflow and for code to be hidden within the packet. We can see in the code below that smb_com_nt_transact is used, as that is what will allow us to trigger the bug. Additionally, we can see a fixed offset being created as well. Both of these are what allow us to create additional room in the packet in order to hide malformed code. The third step is connecting to the computer and sending the corrupted packets as a transaction2_secondary. The screenshot below shows the information of the local Windows server hosted via virtual machine that we are going to use the Metasploit framework, which will use EternalBlue, which will use the CVE-2017-0144 exploit to attack. Using the Metasploit framework, we will set the required information that the host needs to run. We set the receiving host, the payload, and the listening host, as well as ports. After running EternalBlue in the Metasploit framework, we can see the following results in the screenshot. In the first few lines, we can see that we are trying to connect to the target for exploitation, followed by the connection being established. This is successful. A few lines down, we can see the packet being sent. We can then see the response back from the exploit packet, followed by EternalBlue completed successfully. Using sysinfo through meterpreter, we can see that we have connected to the VM successfully. In our example here, the only attack that has been done is running sysinfo. However, in a more real situation, this would be much more destructive. EternalBlue acts more so as a gateway that focuses primarily on memory, and for this reason, it does not leave much of a signature. If one does not catch what the packet has done before the memory has been wiped, it is not likely to leave a lasting signature. While EternalBlue does not leave a signature itself, the activities afterwards can. This includes TCP ports being open to Tor networks, or a direct connection to the attacker's most recent connection. The issue with the EternalBlue signature is that the attacker can delete whatever they may leave behind. But the important thing is to check the SMB transfer logs for packets.
I'm going to talk about how to protect against the exploit, and as we've mentioned before, this vulnerability has been known about for a long period of time, so the updates from Microsoft that are necessary for getting rid of this issue are already available for download. But if the system doesn't have the most recent patch installed, it can still be vulnerable to the exploit. The best thing that a user of such a system can do is to check the latest updates through the help menu. Subsequently, the Windows will install the MS17-010 security update, and the system will be secure against the exploit. It is now all in the hands of end users. Section 3, Security Policy. Knowing that this exploit is still an issue that's relevant today, the best thing to do to keep one's network safe is to ensure that all systems have the latest updates installed. The only reason that EternalBlue is still causing people problems in 2019 is the lack of updates. It is also advisable that the security policy has a policy about external connections. The host computer shouldn't be accessible from the outside, and it should reject any outside connections. A specific classification of this exploit must exist in incident reporting. The title would read CVE 2017-0144, and the cause, failure to install the MS17-010 security update.
And that's it. That's all we have for this video. We hope that you were able to learn something new about EternalBlue exploits. We hope that you were able to learn something new about information security, and we hope to see you here again soon. If you have any questions, feel free to drop them in the comments below. And that's it. Until next time.